Hi everyone, this is Dr. K, making, I hope, a short video to show you how to solve time value of money problems. Looking at this worksheet, this is also how I recommend you set up your homework. It would normally be one problem per worksheet. So we're going to take a look though. You have your given information and what the question is. The given information organizes it for you to make it easy to solve. Having the question in front of you helps you understand what it is you're solving for. And sometimes a problem will have multiple parts. So by having the question, each part written out, means you won't forget or miss answering a part. All right, so for this first one, an investment pays $65,000 at the end of 7 years. Interest rates are 3.25%. The question asks, what is the value of the investment today? This information would be important if you were trying to determine whether the cost being asked to purchase it were worth it or not. So we're going to take our given information and fill in our time value of money variables. For most purposes, unless it's a series of payments, we don't need the type. That refers specifically to when payments are made. So I'm just going to black that out for us. So it pays $65,000. That's a payment, but it's a one payment, not a series. So it is not payment. The payment in these problems refers to a regular ongoing series. There is no ongoing series, so payment will be zero. Let's not get that confused with the $65,000. It pays $65,000 at the end of 7 years, so that's in the future. So the future value of the investment is the $65,000. Please note, I am using what's called cell references. I've typed the information once, proofread it to make sure it was correct, and now all I'm doing is using a cell reference to pull that information over. The 7 years is our N or N per, number of time periods. Again, type in equal, click on the 7, hit enter. The interest rate is given at 3.25%. So again, instead of retyping information, risking a typo, I'm going to do an equal sign, click on it, and hit enter. So all the information it gave me is now accounted for. So what I have to calculate is the value today, which is our present value. The Excel function for that is equal PV. And when you're typing, it will pop up, and it will also tell you what that function does, so you can be sure you're getting the right one. Excel then tells you in what order it needs the information. It needs rate. Click on the rate, comma, because that's a separator. Number of time periods, that's the 7, comma, PMT, which is payment. There's nothing there, but we have to tell Excel that it's a 0. And then the future value, which is there, and then we're not using type. And you can just press enter. Now, two things. One, the interest rate was 3.25%, but here it only shows 3% because you have to set it for 2 decimal places. To fix the display, simply come up to the command ribbon to the number group, and there is an option to increase or show more decimal places. Click that twice and it will display correctly. Second, notice the present value is negative. that does not mean it is a negative value. It is negative because it is a cash outflow to you. In Excel and time value of money, there are cash inflows and outflows. A positive value, like the 65,000, is an inflow to you. That's what you receive. It's assuming that you would have to purchase the investment to receive the benefit. Therefore, today's value of the investment is expressed as a negative number because it is an outflow. If you want to be clear, you can edit where it says equal, put a minus sign after the equal before the PV. It will display it as a positive value. So what is the value of the investment today? The value of the investment today is $51,961.65. As a standard, always show values to 2 decimal places. That's present value. Let's take a look at the next part. Given information, you borrow $62,000. The interest rate you pay is 6.5% annual. The loan term is 6 years. The question we have to answer is, what is your monthly payment? Okay, so again, type doesn't matter because it isn't telling us at the beginning or at the end. So we let Excel default to its standard. You are borrowing $62,000. That means at the time the loan starts, you are receiving $62,000 in cash. We'll do a cell reference for that. The future value, when you make a loan or you take out a loan and you're making payments, your goal is to pay it off. So therefore, the future value of the loan is going to be 0. You're going to pay it off and get rid of it. The loan term, the loan interest rate is 6.5% per year. So I stands for interest equals 6.5%, but that's an annual rate. And the question is asking, what is our monthly payment? So we will divide by 12 because there are 12 months in a year. And again, to show 2 decimal places, go to the command ribbon number group and increase decimal places twice. Payment is what we have to calculate. So I'm just going to go ahead and highlight that as yellow. All answers should be highlighted. The N, or N per number of time periods, is going to be 6 years. But again, we're being asked the monthly payment. So it won't be 6 payments. It won't be 6 time periods. It will be 6 times 12 because there are 12 months in a year. So the number of time periods or payments is 72. Now we can calculate the payment using the function equal PMT. Again, it pops up, tells you it's calculating the payment for a loan. Double click to select that. It wants the interest rate. We have it, comma, the number of time periods. Click on that, comma, present value, comma, future value, and we're ignoring type so you can enter. And again, this shows as negative because it is an outflow from you. So you will make a monthly payment of $1,041 $42.22 each month for 6 years to repay that loan. Next part, again, the given information from the problem. You save $1,000 a month for 20 years, and it earns 2.75% per year. How much will you have at the end of that time period? We're going to do the same process. For purposes of this section, going to ignore the type. If we go down these variables in order, the present value of the account is 0. You are just starting, so there's nothing in the account. If let's assume this is a savings account at the bank. They didn't give you any money. You start with 0 when you open the account. The future value is what we want to calculate. How much will you have? That's off in the future. So we'll just mark that as a highlight. That's where our answer will go. I is the interest rate. The interest rate you will earn is 2.75 per year. But notice we are making monthly payments. So we're going to express our time in months because the payments are going in months. So we're going to take our interest rate and divide that by the number of months in a year. Our payment is going to be negative. It's shown as a positive, but remember, there has to be a cash outflow to get a cash inflow. And in this case, we are paying $1,000 a month into the bank account. So we're going to make that payment a negative $1,000 because it's leaving our pocket to go into the savings account. The N, or N per, is the number of time periods. That is going to be equal to 20 years, but our payment and our rate now are on monthly, so it is going to be 20 times 12 months in a year. And again, I'm going to come back, fix the interest rate by adding 2 decimal places to the display. We now have all of our variables accounted for. We're going to calculate the future value of this account by using equal FV. Select it. It needs the rate. We have that, comma. And notice sometimes it will cover up, but as long as you click that cell, it will work. The number of time periods will be 240 months. The payment is $1,000 a month that you will be paying into the account, and the present value is 0. Some people will skip the last value. I recommend against this except for type. It is better to get in the habit of putting in all the values because otherwise you don't develop a consistent habit and more mistakes happen. Look what it did. All that means is the value it's trying to show is is too big for the column. So we're going to adjust our column, and now we can tell that $1,000 a month for 20 years at 2.75% interest rate means that at the end of the 20 years, we will have $319,489.19. Let's go down again. Given information. You are saving $15,000 per year for the next 7 years. Your goal is to have $120,000 at the end of that time. What rate of interest do you need to earn? So, present value, just like the problem above, is 0. We're going to just start savings. Our future value. Our future value is going to be the goal. We want to reach that goal of 120,000. The interest rate, that's what we don't know. So I'm going to highlight that field. Our payment is equal to $15,000 a year. And again, it's going to be negative. We're going to take the 15,000 and deposit it into the investment. So it's an outflow from us and an inflow to the investment. The N, or N per, number of time periods is given as 7 years. Type. We've been ignoring it. Type refers to whether we are making the payment or receiving the payment at the beginning or at the end of a time period. And like I said, for simplicity purposes, we're ignoring it, but it is there, and you may run across a problem that requires you to use it. We'll look at that later. To calculate the interest rate, the Excel function is equal rate. Equal rate tells us it would like the number of time periods. That would be 7 years, comma. The payment, we have that as 15,000, comma. Present value is 0, comma. And future value is our goal. Now, if I put a comma, it's going to ask for type. And we're not going to use that, but I want to show you in case you have a problem that needs it. So when you put the comma and it rolls to type down here, it tells you you have two choices, 0 or 1. 0 is the payment is made at the end of each time period. So in year 1, the payment would be made at the end of the year 1 and at the end of year 2 and so on. The other option is a 1, meaning it's paid at the beginning of the time period. So the first day of the year 1, first day of the year 2, first day of year 3, and so on. If we don't give it a type, which we're not, it will default to end of time period. Now, there will be a difference in value. So if your problem does not tell you when the payment is made, let it default. But if it says you make the payment the first of the year, then you want to go in and use type. That's what it's for. Now, this one also says guess. Literally, Excel will allow you to try to guess what the interest rate is, to throw in an estimate. I don't see any point in this. We want Excel to calculate the correct rate for us. So when using equal rate, I recommend, if there's nothing specified, ignore type and always ignore guess. It says 4%, but remember, we need everything to 2 decimal places. And we do that, we see it's more than 4%. For us to reach our goal of $120,000, we must find an investment that pays at least 4.42% per year. All right, one more. Our given information. You inherit $150,000 and buy an investment that pays a return of 9.75% per year. This is obviously a good investment. That's a good rate of return. Not great, but good. Your savings goal is to have $1 million. Question: how many years until you reach your goal? Again, Same setup of variables. We're not going to worry about type. The present value. What is the starting value? In this case, it's the $150,000 you've inherited. We're going to make that a negative because you're going to take the $150,000 and you're going to purchase the investment. It's an outflow from you into the investment. Future value is going to be your goal. Equals, we'll click on the $1 million, hit enter. I, the annual interest rate, equal, click on the interest rate. And again, it's rounding, which we don't like, so let's clean that up to 2 decimal places. Payment. In the given information, there is nothing that says you're making any payments, so that will be a 0. And by the way, payments can be made or received, but there's no payment in this problem. Now we're down to N, or N per, number of time periods. Well, that's what we need to calculate. It says how many years until you reach your goal. So we have to calculate the time. In Excel, it's equal N per, select that, the interest rate, the payment, the present value, the future value, and then the type, which doesn't apply because we're not making a series of payments. Press enter. And the number of time periods is 20.391. That's too many, right? It just goes a lot. So this time we're going to make that cell active, come to the number group at the top, and we're going to decrease decimal place till we get it down to 2 decimal places. So this is 20.39 years. So less than half. 20, just under 20 and a half years. And then you will have your $1 million. That's how to use Excel to solve time value of money problems. I highly recommend you set up your homework every chapter with the given information, the question being asked, your solution, and highlight your answer. Sometimes it may ask you, okay, using this one, it says, what is the value of the investment today? You calculate it. It may have another question. It may say, if the price of the investment is $50,000, should you buy it? Okay. So you want to put all the questions. Just looking at the value, you invest 50, it's really worth today. This is not how much you would make. You're going to get the 65,000 at the end. The price is 50. The value is almost 52. So the price is less than value, meaning it's on sale. You can buy something worth 52 for 50. Should you buy it? Yes. The value is greater than the price. And then highlight that because that's the answer to the second part of the question. Okay. This is solving time value of money problems.